Cool. Well, thank you, everybody. Great to be back at Next Build in person. It's been a shame, again, the last couple of years we've had to do things remotely and hybrid. But thank you for everybody for spending time this afternoon. So my name is Mike Leach. I'm the Senior Manager for our worldwide solution portfolio within the Lenovo Workstation BU. And I wanted to speak with you today a little bit around some of the technology revolution versus kind of evolution. So to get a bit of context in the background, so we've seen a lot of movement in technology over previous years. You know, I could stand here last year and the year before and show you the next gen and the next gen and what's new. But a lot of the time it's an evolution of what happened before. So to kind of just run through, that's a timeline. I'm not going to bore you with a lot of slides, and I do welcome some questions on the fly. But if we look at what we had in our portfolio back in 2014, we had an awesome mobile workstation. The industry focused on a mobile workstation. We had one product. And over the course of the last sort of 7 or 8 years, the industry has evolved. You as customers within this industry, you've demanded more performance, you've demanded different form factors, smaller screen sizes, bigger screen sizes. And as you can see, we ended last year with 7 mobile workstations. And looking at it, you know, natively, performance got better the bigger the screen size. You've got more space to fit things in. We can drive them faster and harder. As technology got newer, obviously the newer the product, the faster it was, so you'd replace old equipment with new equipment. But then we saw for the first time ever, obviously during the pandemic as well, is how performance now went both up and down the technology stack. So by going into a smaller screen size, you didn't necessarily then limit or inhibit the performance and capabilities of what your software can do. And using things like our remote workstation software, TGX, you were able to drive pretty much any workflow from any location at any time. And we saw the same on desktop, so I won't bore you with all the animations, but we started 2014, we had 5 desktops to suit each key area of the market, each key type of software workflow, we had a product and form factor to suit. And at the end of last year, we nearly doubled that with no fewer than 9 products. So what we've done, we've evolved the portfolio in line with what customer feedback is from yourselves, what the industry's demanded from our ISV partners, to make sure that we give you the right performance and the right form factor to do the right job. And obviously the pandemic very much put a spotlight on the portability and the flexibility of that. But obviously we've had a fantastic portfolio to do so. Now, within a workstation, obviously you've got a lot of component considerations. So more or less of a science lesson, but I wanted to showcase obviously the CPU is probably by far the most important piece with any computer workstation. All the software applications that you run demand a fast, powerful processor. The bigger the projects, the bigger the data sets, obviously the more important it is to not skimp on what is your CPU. Our technology partners from Intel, you know, if we go back 3 or 4 years, and I'm going back 3 or 4 years just because typically most people will refresh their hardware every 3 years. I could go back further. But if we look over the last 3 or 4 years, you know, right up to kind of last year, so Intel brings out a new generation processor, Core i7, 7th gen, 8th gen, 9th gen. The sticker looks the same-ish, you know, so you pick the laptop up, it looks the same, it's black with a red dot, so therefore you just use the mobile workstation maybe that you have. And if we look at the text underneath, the TDP, the thermal design power from Intel, the thermal envelope that we operate in desktop was 65 watts. And if we go back over 3 or 4 years, you get between 6, maybe 8 cores, about 4.9, 5 gigahertz. We've basically swayed a little bit, but ultimately there was no radical change between something 4 years old and something that we maybe purchased last year. Fast forward to this year, and this is where this is more of a technology revolution versus the typical evolution that we've seen. So whatever we presented last year, great performance, great value, but this year was a fundamental change from Intel in how their CPU architecture is built. So we've got up to 16 cores. I'll cover a little bit more about that in a second. We've obviously broken the 5 gigahertz barrier, and we're still within that magical 65 watt TDP. And obviously that denotes then how physically large maybe that workstation can be. So the 12th generation is called Alder Lake. There are variations in Alder Lake, depending on whether you want something thin and light with all-day battery life or something with all the bells, all the whistles, and really high performance. But the Alder Lake architecture is up to 16 cores. Now, for the first time, they're not all the same. So the cores are built up of P cores for performance and E cores for efficiency, all within that same die. So the CPU is actually physically larger in size, it's rectangular in shape, But for the first time, we've now got performance cores and efficiency cores that run side by side. So you can assign what parts of your workflow, which software applications run on certain cores. So you don't just run one application. If anything, IT are monitoring what you do in the background, maybe email, security enhancements, all those suck away performance typically from your normal work stream. So if you can run that on efficiency cores, obviously then you can allocate a lot more performance to the mainstream tasks that you're there to do, so you can do more with less. So we've got up to 8 cores efficiency, 8 cores for performance, and then a total of 24 compute threads. So we're giving you more performance inside that same thermal power, which is kind of fairly revolutionary when we look at CPU. Looking at the other ones, we've now gone to DDR5. Previously it was DDR4 memory, up to 128 gigabytes on this particular architecture. Huge amounts of memory bandwidth, so memory data sets are getting bigger, data sets are getting larger. You need more RAM inside the system, but if you don't speed up that RAM, it's like having a highway with just 2 lanes. If you've only got a 50 mile an hour speed limit, doesn't matter how much data you've got to get down there, you need to have obviously the bandwidth. So the extra bandwidth, 4 lanes, 8 lanes, 10-lane highway, obviously you get a lot more performance there, and the data is obviously more readily accessible. And everything is natively now running on PCI Express Gen 4. So everything you have in that workstation, be it storage, be it graphics, be it Ethernet, can now be accessed much, much faster. And unlike previous years where things have just been slight tweaks, this is very much that technology revolution. And then moving on, you can see just against last year, so 12th gen versus 11th gen, if you can read the red text, we're looking at practically 2x the performance from a previous generation. So if you've got a workstation that's maybe 10th, 9th, or even 8th gen, then you're going to see some fairly substantial performance improvements for the same kind of price bracket as maybe you looked at when those original systems were deployed. Moving on to GPU, so flip that coin over. Obviously CPU is very important. GPU is by far the next important component to consider. Partnering obviously with NVIDIA. A similar look here. Their architecture changes at a much slower pace. They don't have a new GPU that comes out every single year. But if we look at the mid-range GPU architecture going back the same 3 or 4 years, these were table stakes in every mid-range CAD workstation. The 2000 class GPU from NVIDIA, we can see they have a 75 watt total graphics power, so the same thermal envelope. And we were seeing about a 25 to 30% performance increase generation to generation. So everybody within that price bracket, you could roughly guess where you were going to go and how big your models could get. Now moving on to this year, it's the first time we've ever seen their new ray tracing, the RTX GPUs in a mid-range space. So we actually have one of these on the booth to take a look at, but this is an extremely powerful graphics card in a mid-range space. So whereas before you had 4 or 5 gigabytes of memory, we've now gone up to a whopping 12 gigabytes. And this GPU itself is significantly faster than anything before in this same price bracket. So it's VR ready, we've got a lot more memory bandwidth, a lot more memory frame buffer itself. We've got ray tracing cores for all the new RTX enabled applications like NVIDIA Omniverse. And we've now got AI tensor cores as well. So this is very much a Swiss Army knife of GPUs that can do everything you throw at it, but still in a small, low profile form factor. And I wanted to highlight, and that's just the mid-range graphics. So obviously NVIDIA have higher end GPUs as well, but table stakes, Revit, AutoCAD, those mainstream 3D CAD workflows, everybody will use a mid-range GPU to start with. And obviously what we've got here is that performance does get even more impressive the further you move up that GPU stack. So they have the 2000 class, there's a 3, 4, 5, and even a 6000 class GPU. But they've now lowered that cost of entry where the RTX GPUs used to be very high end, and they've now come right down now to sort of start off on that mid-range. So why is this important? So I've put up the clock and the hourglass here because obviously time is money. But I guess more importantly, wasted time is even more expensive. Obviously, I'm speaking to a wonderful room of architects here, but a workstation for us, it's a computer. It's probably boring for you guys, but for us, it's the fundamental foundation that you build all of your work streams on. So you can't build a multi-story building on weak foundations, so you have to make sure that you've got the right pieces and parts in place, and they're optimized then to deliver the best for each of your individual work streams. Hands up in the audience who uses Revit. But I guess everyone's use case within Revit is going to be slightly different. So just saying I use Revit probably isn't enough. So I wanted to highlight here some of the important things to look at and fundamentally how this revolutionary new architecture can obviously can help. So I've got a couple of videos. These have been sped up slightly, but we've got last year's workstation on the left. And obviously, so apologies for those that bought last year's workstation because we're going to embarrass it a little bit. But this is just a CPU render. And this is just showing you how much faster we have here from last year's workstation on the left to the new 12th gen stuff on the right. So for us, the one on the left is still going. I wouldn't shy away from a 13-second render, but when you can do that, in 8, that's obviously significantly different. So we are seeing a 65% performance increase like for like. So for those of you that do anything CPU-bound, CPU rendering is a good example. That's where time can be very expensive. And then moving on to Revit. So this is it's more of a boring video, but we have a benchmark here. It's sped up a lot, so apologies if you close your eyes for a few seconds. But ultimately here we have last year's graphics, the mid-range Quadro 2200, and then this year the new RTX A2000, running the exact same benchmark. But essentially what we have now is the end results, which come up here. Yeah, so smaller bars are lower bars are better. But just on GPU alone, and I know Revit's not the most revolutionary GPU application out there, but for those just working in complex models, we're delivering 28% more performance on a non-optimized application. So just the GPU itself is going to make you 28% more efficient. And then using the GPU for other applications. So an example here, I won't bore you with a multi-hour render video. This is just a screenshot from V-Ray using the GPU to render. And I wanted to highlight here where the frame buffer is really important. When you render on the GPU, you need large amounts of GPU memory to insert and render that same model. Having 12 gigabytes in a mid-range card now means that you can produce very quick, very simple renders. But if you do run out of memory, you are going to get very sort of major issues. You might start the render, go away for lunch, come back and find something has crashed. So don't underestimate how much GPU memory you need. And I'd probably say look at all the applications that you run, knowing that they all need GPU memory. And then you'll layer them on top of each other because you'll leave the render running in the background and then come back and maybe do other tasks as well and realize, well, it crashed and it should have finished an hour ago. So don't underestimate, and I'd say if you look at the amount of memory you need, double it, and that would give you the headroom there to give you that sort of 2 or 3 year life cycle out of that hardware. So to optimize this, so everyone in the audience here probably uses a similar software stack. I'd ask a fairly similar set of questions, but optimizing each of your workstations for each of your workflow might be slightly different based on the size of the models, what applications you run, and how you use them. So for me, it's all about you're trying to find, essentially, you're building an equilateral triangle here. So looking at CPU, GPU, memory, storage, it's a fine balancing act to finding the right ones for your workflow. You could just go very high end on everything, spend a huge amount of money, and then one cap fits all. But you might be sat there with a workstation that you're barely touching the sides on. So it's not a great efficient use of your budget. I'm happy to take orders for a large high-end workstation, but we want to make sure that you invest the right amount of money in the right tools. And obviously, this underlying foundation here is very important. So looking at the CPU, you've got core counts and you've got clock speed, kind of two opposing forces. As you increase both, so does your amount of power consumption comes in. So looking at the more of the sustainable workflows, unfortunately, as you go faster, they do use more power. So we have to find that balancing act. Same on the GPU. Do you want stability or do you need kind of raw performance? And sometimes you need to compromise. And NVIDIA have a full enterprise stack of GPUs that are built to do both, but they also have gaming products. They also have consumer-focused products, and it's making sure you pick the right GPU. And then on the storage, kind of capacity versus performance. If you want performance, you sometimes don't get the capacity, and if you want capacity, then you have to sacrifice something. So it's all about finding whereabouts in that triangle your data point kind of sits. And I'd say, I'd like to show you a recipe card that's guaranteed to work with everybody, but obviously there is a few kind of questions to overcome. So this is the portfolio we have on desktop. This is a very similar set of use cases that we see across the industry. And I'd kind of ask some questions. The first one, working with your IT teams, is understand the ISV applications that you run. And it's not just the names and the titles and the minimum spec, but understand how you work with it. So within Revit, there are application pieces and tools that run on the clock speed. So everything with a faster clock speed will run faster. But there are pieces in there that utilize core count. So you need to find, are you spending 80% of your time on a clock speed task or a core count? And find whereabouts you are on those. How large are your data sets? Not just today, but what's the project going to look like in 2-3 years' time? Because you've got to give yourself headroom to support that. For rendering, are you rendering on CPU, GPU, or both? And again, lots of tools today are CPU driven, CPU rendered, but we are seeing more and more tools come into the workstream that obviously render on GPU. Is your data storage kind of local? Do you need to have offsite or on-premises storage? Is it local or network-based? And then future-proofing. So look at the applications. I know you guys kind of lock yourself into a certain version of Revit for the project, and then you might have to wait 2 or 3 years before you can update, or you might have to run 3 or 4 versions of Revit to support multiple projects. But make sure you're future-proofed. Look at what's coming from Autodesk in the release notes for 2024 or 2023, because you want to make sure, again, it's an IT hurdle. They'll make a purchase and they'll replace it when it's broken. So you need to make sure that you've got enough headroom to support where that software is going to go, so that when you migrate to the new versions, you don't all of a sudden just grind to a halt because Revit changed their graphics engine and you didn't have a graphics card that could support it. So with all the money you spend on software, you need to make sure that you've got the hardware there to back that up. And then the same on the mobile side. We see a little bit more on mobile where we have a broader portfolio. There's some new models out on the booth for you to take a look at where we've re-engineered the art of what's possible in a mobile workstation in the last 12 months. So I'd have the exact same questions to ask on desktop, but essentially for mobile, screen size, people choose a form factor based on their job role. But as you increase the screen size, obviously the weight and the size increases. What resolution do you need? Most people go out and buy a 4K TV, not appreciating that when you move to 4K, you're driving 4 times the amount of pixels. So all of a sudden, you're asking 4 times more of that workload on your GPU. So just because you've gone with a bigger screen and more pixels means that your graphics card all of a sudden is being kicked to the curb a little bit. Is weight important? Are you just transporting it from the office to home, or do you need to work on the go on a train or from Starbucks type thing? Docking. So all our mobile workstations can be docked. So do you need all the ports, or can you have the ports on a docking station? Battery life. I'll say want or need. Who wants all-day battery life? I would put my hand up straight away. Do I need all-day battery life? Well, within ThinkPad, we have something called rapid charge. So plug yourself in, and within an hour, you can get 80% of your full charge battery. So for the half hour I'm on a train or the 10 minutes I'm in Starbucks, I can keep my battery topped up. So actually, I don't have to compromise on a bigger, heavier laptop with a bigger battery because I can utilize tools and features like rapid charge. So that want and need, finding that balance. Everybody wants something wafer thin and super light, but the laws of physics prevent you from getting all the performance you need to get your job done. So it's finding those right tools. Do you need wireless WAN, 4G, 5G, or can you maybe tether off a mobile phone? Do you need that connectivity away from a Wi-Fi connection? And is it really kind of a remote user or maybe a hybrid user? So for those that maybe want to work from home 3 days a week, do you give them a big P16 to do their work, or can they get by with something like a P14S and actually remote into the workstation that you've bought them in the office? So you can use something like TGX, our remote workstation software, to allow you that the laptop just becomes like a client device, an interface into your workstation in the office, so you can work from anywhere. So maybe when there's a train strike or a pandemic, then essentially you've got that flexibility of not having to move the data around. You can just pixel stream into the office. So all great questions to ask, and I'd say anyone looking at workstations, those are common questions. The ones in white, obviously more so for mobiles. And I think there is a common set of responses, but it's finding the right tools to give you guys obviously the sharpest tools, the sharpest and the most performance to get everything out of the software that you invest heavily in. So I wanted to move on now just to kind of cover, I guess, sustainable workflows, and I guess just to remember kind of like more sustainable IT. So we've got a great booth experience from Actual up on the exhibition floor. I would like you to take a look. But all of our workstations now, when you're investing in them, just look at recycled packaging. Are the vendors looking at sort of more post-consumer kind of recycled plastics and materials? The new P360 Ultra that we launched, the ThinkStation, awesome platform. We've made it smaller, which means now we can ship more of them in smaller packaging. So we can do bulk packaging. So for those buying larger volumes, we can now ship things more efficiently around the world, reducing our and your carbon footprint. And then obviously the platforms themselves are even more power efficient. So you can do more with less power. We've even got things like CO2 offset, so we can obviously help you achieve your carbon neutral goals. But as a final side-by-side, taking last year's workstation, we're delivering 62% more performance per watt. So if you are looking at carbon neutral, the amount of power it's taking to deliver your projects, boiling it down to the nuts and bolts, that we are now significantly reducing what that electricity or that air conditioning bill could be, which can kind of then all be factored into helping everybody obviously be more sustainable and more green, as everybody is inclined to do so. And any questions? Yes, Greg.
1 second.
Greg. Thank you. So I've got a question about your mobile workstations.
Yes.
If you're running them when they're plugged into the mains,
Yeah.
what kind of if you're just running it off battery, what kind of performance difference would you get? Because you presumably can't feed the amount of watts that the processors need to run at their full
So
capacity.
when you plug a laptop in, essentially it's running like a desktop replacement. When you're running it from battery, we have something called ultra performance mode. So when you click on the battery in the bottom right-hand corner, you can change a sliding bar to give you like maximum performance. I'm only going to be 10 minutes, so I just need to nip to the, up down the corridor, and I can still sustain desktop performance. Or you can slide it right the way back to kind of like, very long battery life, but limited performance. So you can change that as part of the user experience. And as a user, you're in control of that. But there are varying degrees. Every notch you move down will slower the CPU or slower the GPU to obviously suit. If you want 10 hours of battery life, it is available, but maybe not running full fat performance all the time. So.
But are you actually able to get the same level of performance if you put the slider up?
Yeah, if you go to ultra performance mode,
Yeah.
whether you're plugged in or on battery, then in theory it's the same. But just don't expect maybe the quoted battery life at that particular instance.
No. Okay, that's interesting. Thank you.
Okay.
Another question over here.
Hi. Your presentation was concerned mostly on architecture and rendering, but the civil engineering calculations of structural model are also important and also take a time. So do you investigate also your products in case of software like Tekla and also calculations in Autodesk Robot and so on?
Yeah. If I go back a couple of slides, that's probably why I maybe skipped over those a little too soon. So obviously our portfolio is fairly broad, everything from the tiny workstation on the left to our bigger P920 on the right. I focus quite heavily on the 12th gen architecture for this year, just because Intel have just launched it. That's everything P360 based. As we move up the stack, our P7 and 920 being 2 CPUs, they're built more heavily for some of the structural simulation and analysis workflows. They're physically larger units, but the examples I've given on efficiency and performance were specifically on the 12th gen Intel CPUs. So we have platforms to support that. They just weren't. I didn't double click on those for the presentation today. Okay.
So in building on this question here, we talked a lot about the 360 Ultra and typical AEC workflows. What about AI and data science? Do you see the latest Alder Lake architecture suitable in the Ultra for entry-level data science AI workflows, or should we be looking at?
Data science, it's almost its own topic in its own right, but so machine learning and deep learning are, they're heavily CPU or GPU intensive. So a lot of the deep learning stuff, machine learning as well, is done heavily further up the portfolio. But once you've created that AI model, if you need to kind of then inference maybe data collection at the edge, then we are seeing the Alder Lake platform is very good just for its form factor and size. And because we can do a great combination of CPU and GPU, then anything that's done sort of inferencing, smart buildings, you mentioned some of the data collection as well. when you've created so much data, you can't send it up to the cloud to get your answers back. So being able to inference in real time, we find that the Tiny's been very good for us in that space, but it's limited on CPU, GPU, just down to the laws of physics. So the Ultra is that next step up that it opens up a lot more space for that. But it is a growing trend, and it's a growing area now where people need, the answer isn't in the cloud. There is no such thing as the cloud. It's just somebody else's computer. So being able to get your data up and back to get the results, even with 5G, there isn't the bandwidth to do so. We're creating so much data now at the edge, wherever that may be. Being able to get the answers quicker, like a federated network, you'd have all your edge devices talking to each other, and then periodically just sync with the cloud to keep the data collection up to date.
Excellent. Thank you, Mike.
No problem.